Here's the explanation for the extension part of the unit circle mock. Okay, does this equation have any solutions between theta is between 0 and 2 pi? Remember, 2 pi is 360 degrees. Okay, remember, cosine of theta can be interpreted as the x-coordinate of the unit circle. So if you have the x-coordinate, and we're talking about negative square root of 3 over 2, I have two possible reference triangles. I have this one and this one. Okay, what are the measurements of these angles? It would be 30 degrees here, and it would be 30 degrees here. Okay, square root of 3 over 2 is this distance right there, the longer side of the 30, 60, 90 triangle. Okay, so how many solutions it has? It has two solutions. Okay, and what are the solutions? Well, one of the solutions is here to here, and the other solution is from here to here. Okay, so the smaller one is equal to pi minus 30 degrees, which is pi divided by 6. So that's equal to 5/6 pi. This bigger one here is equal to pi plus pi over 6, or 30 degrees. 180 plus 30 degrees, which is equal to 7/6 pi. So those are the two answers. Okay? All right. Let's go to the next one. We are going to graph the sine of x over 2 minus 2. Okay? First, we're just going to graph normal sine. Normal sine looks like this. Okay, that's normal sine. Now we're going to graph sine lowered 2 units. If we lower sine by 2 units, we're going to have this, right? This is sine lowered by 2 units. Okay, we did that. Okay, now we're going to adjust the period. Okay, so here the period is, let's check out this inside part of sine over x. If we have x divided by 2, our b value turns out to be 1/2, right? If our b value is 1/2, b is also equal to 2 pi over the period. Okay, so I'm going to write that. Now we can find the period, which is the length of one full cycle of the sine, by doing algebra here. We have 1/2 equals 2 pi over the period. So we're going to multiply both sides by p, and we're going to get p divided by 2 equals 2 pi. Now we're going to multiply both sides by 2, and we're going to get p equals 4 pi. So the length of one of the period of the sine function is going to be 4 pi instead of 2 pi. Whoa, it's going to get really long, right? So it's going to be stretched twice as long as it usually is. So this is going to be sine, and it's going to extend off in there. You can't even see it. And then the other half of it we could draw here like that. Okay, so the sine function is totally stretched now. And it's been lowered to a height of -2. The center of it has, anyway. Okay. Let's go to the next one. The next one is verify the identity cosine of x plus sine of x, quantity squared, equals 1 plus sine of 2 of x. Okay. This is actually a pretty quick one. First, we need to see that we need to do FOIL here to expand it. So if we do FOIL, we're going to do square root of that, a square root of that, and then we're going to take 2 times sine of cosine. So we're going to have cosine squared x plus 2 sine x cosine x, and then the last term is going to be sine squared x. Okay? Then we need to be on the lookout, because if we have sine squared plus cosine squared, we know that if we add those up, we'll get 1, right? So we're going to do 1 plus 2 sine x cosine x. Then we need to be on the lookout again. We just replace cosine squared plus sine squared with 1, right? Now we need to be on the lookout again, because 2 sine cosine is an identity. 2 sine cosine happens to be equal to 2, or not 2, but sine 2x. And what do you know? We've proven it. Okay? All right. Now we're going to find an equation for the sine graph below. Okay. So, first of all, I'm going to look to see what a is. We can find A by finding the height of the sine function. The height of this sine function turns out to be 1. That's kind of weird. Usually the sine function is a height of 2, right? Usually it goes from -1 to 1, which is a height of 2. This has a height of only 1. So that means that the amplitude, or A, should be 1/2. Okay? Then we'll put sine. What about B? B is equal to 2 pi over the period. What is the period here? Let's see. What is the full period of this sine function? It turns out that right here we're looking at a period of this many units. It looks like it's pi over 3. So the period is pi over 3. We're going to substitute pi over 3 here. And we're going to get B equals 2 pi divided by pi over 3. So the pi's cancel out and we end up with 6. Okay, when we divide by 1/3, that's the same thing as multiplying by the inverse, so 2 times 3. So our B value is 6. The C value we determined by phase shift. And in this case, we're working with sine, and this sine is not phase shifted, right? Because you can see that sine, if it starts at the 0 point and it goes up, it's not phase shifted. It's exactly where it should be. So the C value is 0. And then the D value tells you how far it's moved down or up. And in this case, the center of the sine function has been moved down from 0 to -4. So the D value is going to be -4. Okay? And so that's our answer. And that's it.